On the next slide we've got an image of the North American Nebula, and it does look a bit like North America, doesn't it? In fact, that would be California, sort of, Mexico. There would be the Gulf. There's the eastern seaboard. Use a bit of imagination, might be able to pick out the North American Nebula there. It's made mostly of hydrogen gas, which is what that lovely pink glow is, characteristic glow of hydrogen. The edge here that you see is known as an ionization front. And that's typical of a mission nebula. This is gas that's being ionized by stars that are powering the nebula, and then there's an ionization front here because the material on the other side is actually cold and dark, has not been excited by the stars inside the nebula. On the next slide I've got a copy of the Veil Nebula, which you can see. This is a supernova remnant. It's one of the most spectacular ones in the nighttime sky. It's about 1400 light years away, and it's the remnants of a star which blew itself apart around about 10,000 years ago. This is what we see today, but when it exploded, it would have probably been bright as the moon in the sky. The death of a massive star. Most objects that are identified as deep sky objects, they're usually called with what they look like in a small telescope. So the North American Nebula looks a little bit like North America. Here is the Pelican Nebula. It's identified as IC 5070. IC stands for the Index Catalog. And this is supposed to look like a pelican, although I just don't pick it out at all. I don't know if you're looking at it, can you tell that that's a pelican? It's very, very difficult to pick out. I suspect this is probably its mouth. Difficult to see. Now this is a bright emission nebula. It's about 30 light years across and around about 1500 light years away. And again you can clearly see the ionization front of that nebula there. The surrounding gas is cold and dark, and then the energized gas inside the nebula itself. Pelican Nebula. We'll then move from Cygnus onto the small constellation of Lyra, the lyre. It's supposed to represent the musical instrument played by Orpheus. He was supposedly able to charm all creatures with his music playing. I'm going to identify and look at in a bit more detail the Ring Nebula, which you can see there. But there are some other things to see in this constellation. The Ring Nebula is probably the most famous. There's a really, really cool double star in the constellation of Vega. It's called the Double Double, Epsilon 1 and Epsilon 2. When you look at it with the naked eye, it just looks like one star. If you look at the same thing in a pair of binoculars, you can tell that it's two, but then if you look at it in a telescope, if it's a decent enough telescope, you can actually pick out that it's 4 stars in the sky. Let's have a look at the Ring Nebula. There's a wide field view, the view that you would get in a small telescope, although the colour there is not really indicative of what you would see in a small scope. Most objects, when you look at them in an ordinary telescope that you and I would own, you don't really see a lot of colour. It needs to be bright, quite bright, before you start identifying colour. In fact, the first colour that the human eye picks out in the nighttime sky is blue. So most objects, when you look at them in a small telescope, appear a pale blue colour. That's what it would look like in a decent telescope. Here is a larger photograph is a Hubble Space Telescope photograph of the same object in the sky. And here what they've actually managed to do is this is produce what's known as a false colour image. So sometimes you can produce just pictures that you and I would be able to see. That's the real colour image. But if you want to identify certain things, that sometimes they're able to pick them out and then label them falsely. So here in this image, red, anything that shows up as red, that is hydrogen in this particular image. Anything that is green, is oxygen, and anything that appears blue is nitrogen. So we can see that when we're looking out into space, we can identify elements that we've found on the Earth. Right in the center of it is the white dwarf star that has produced the nebula. So low mass stars like the Sun, they don't explode in supernova explosions, they won't turn into black holes, they have a pretty boring end of their lives. What happens is the core of the star collapses when it runs out of hydrogen fuel. The outer layers of the star essentially become detached from the core, and then when the core ignites again and starts to burn helium as a fuel, that causes the star to swell up, and it becomes a red giant star, typically hundreds of times the size of the Sun. Now when that happens in the future, we're going to have to leave the Earth, because the Sun's going to swell up to be hundreds of times its size. Imagine what the Sun would be like if it were 300 million miles across. That wouldn't be good for us, because we're only 93 million miles from the Sun. So when the Sun swells up to become a red giant, it's actually going to swallow the Earth. So if we don't leave the Earth, then we're in serious trouble. The Sun's going to kill us one day. Now don't be panicking about it. It's not going to happen for a couple of billion years. But one day the Sun will definitely destroy the Earth. When that happens, for a while we'll be able to live out in the outer solar system, maybe one of the moons of Jupiter or Saturn, or maybe even Pluto itself. We'll be able to live there for a while. But eventually the Sun is going to consume our whole solar system. Here the Ring Nebula is around about 500 times the size of the solar system. And considering this gas that you see is around about 10,000 Kelvin in temperature, that means that we're going to have to learn to leave our solar system completely. Because if we don't, we'll be swallowed and destroyed by the Sun. So there's the Ring Nebula, classic planetary nebula in the nighttime sky. Let's move on then and have a look at this famous double-double in Lyra. It's a good test of eyesight. There's the actual star itself. So this would be a wide field view. In fact, it's a good test for eyesight. And when I look at it, I can just about make out that it's two stars. And when I point it out to students, maybe about 30% of the students can tell that it's two stars. But normally most people just see one star in the nighttime sky. Now if you use a pair of binoculars, the resolution of a pair of binoculars is much better than the human eye, and you can definitely identify that it's two stars. There's the stars themselves, Epsilon 1 and Epsilon 2. Now if you use a powerful telescope, a telescope view is shown along the bottom here, and if the resolution of your scope is good enough, you can identify that each star, so Epsilon 1 and Epsilon 2, each one of them is actually a double star. Here you can see the two stars. They're about 140 astronomical units apart, and they orbit around each other every 1200 years. And then Epsilon 2, it takes about 600 years for those stars to orbit around one another. So it's a double-double. It's actually four stars all in orbit around one another. The famous double-double in Lyra. The Sun's pretty boring in being just a star all by itself. Okay, so we move on then from Lyra to the constellation of Aquila. It forms part of the Summer Triangle, but most of the stars are pretty faint. The brightest star is the star Altair, which means flying eagle in Arabic. Several planetary nebulae that you can see inside the constellation, all are pretty faint, so we're not really going to mention them. It's supposed to represent Zeus as an eagle. Zeus transformed himself into many creatures to the skies, and this is supposed to be Zeus as an eagle.